Well, good afternoon, and today's presentations are about conserving the past for the future, data, websites and software. And we've got three speakers. And the first speaker will be Dr. Jeremy Latham-John, Curator of e-manuscripts at the British Library. And he's been Curator of e-manuscripts since 2003 and Specialist Scientific Curator from 2000 before then. Currently he belongs to the Digital Research and Curation team in the Department of Digital Scholarship. Having first learnt to programme at University College London with Fortran using punch cards, he's been adapting technologies and procedures for forensically capturing, authenticating and making available the digital equivalent of analogue personal archives and manuscripts. He promoted the use of digital forensics at the British Library. He is principal investigator of the Digital Lives Research Project funded by the UK Arts and Humanities Research Council and project lead for the Personal Digital Manuscripts Project at the British Library. He is currently a member of the committee of the section for Archives and Technology of the Archives and Records Association of the UK and Ireland. Jeremy is the first speaker. Our second speaker will be Tim Gollins, who's head of digital preservation at the National Archives. He started his career at GCHQ in 1987 in information assurance. Since then, he's worked on user requirements, systems development, systems design, information management and information security on a number of large government IT projects. In 2000, Tim completed an MSc in Information Management from the University of Sheffield, specialising in Cross Language Information Retrieval. Between 2004 and 2008, Tim was responsible for the secure information management aspects of a large-scale, cross-departmental, highly secure IT and business change programme at the UK Cabinet Office. As head of digital preservation at the National Archive, Tim leads work on digital preservation and cataloguing. Recently, he helped to design and develop the new discovery system for users to find and access the records held at the National Archives. David Holdsworth, Computer Conservation Society and formerly of Leeds University, is well known to us members, and he's specialised in retrieving software and restoring it to working condition. And that's all that was said on the website. But in the latter stages of his working life at the turn of the century, he was involved in collaborative projects on digital preservation, one with Oxford and Cambridge and the other with Michigan. And he came into the Computer Conservation Society, in fact, by sitting next to Brian Oakley when Brian Oakley was president of the British Computer Society and told him that computers needed, conserving computers needed software to be conserved at the same time. And that's how he came to join the Computer Conservation Society. Now, I'll hand over to Jeremy to start with, and then the three of them will lead on from each other. Jeremy will take questions at the end, and Tim will take questions as he goes along. And what are you going to do, David?
I'll take questions on clarity as we go along, questions on policy, let's leave to the end.
Fine. So, Jeremy.
Thank you very much for inviting me. It's a real pleasure to be here. And as you said, I'm the curator of e-manuscripts at the British Library, and I've been involved in two principal projects. One is the Digital Lives Project, which was a research project and involved partners from other institutions. This was one of the forms of dissemination from that project, and partly because it meant we managed to get digital preservation on the front level of Nature, albeit it has to be blown up. And then from the Digital Labs project, we established an internal project that's funded by the British Library itself. It's a 3-year project looking at personal digital archives. So of course, archives papers that we get from scientists and writers nowadays contain digital objects, computer media, computers themselves. And so this project is designed to look at the practicalities of that. And one of the things that we've managed to achieve, it's a 3-year project and we're in our 3rd year, is establish a e-manuscript lab at the British Library, which is divided into 4 functions, what we call digital forensics, enhanced curation, ancestral computing, and curatorial examination. I'll cover those as I go through the talk. A lot of the work is concerned with the management of metadata and storage. I'm not really going to go into that today. We have to think of adaptable workflows that can be easily modified. And we're also thinking about training, and I think, and this actually doesn't exist, it's not a real field guide, but it's an idea of how it would be nice to be able to write and have available a field guide. There is something a bit like that called Mediapedia, which many of you might have come across on the web. But I think this would actually be a very good forum for this kind of work. The project really began in 2000 with a very large archive from this evolutionary biologist that came to the British Library, 200 boxes, of which 26 contained computers and computer media. So we had the normal paper archive, but we also had these boxes, including paper tape from the late 1960s. Actually, I think the earliest one is 1962. It came from a Mercury computer, which I believe was pre-transistor. But there are also quite a few from the Atlas computer. And we also got some computers. Quite a few of them are Macs, but there's also a Silicon Graphics workstation. And we also had this half-inch 9-track reel that he used because he worked for 7 years in the States, and when he came back, he brought all his data on this one reel. And as you can see, we also have a punch card. And one thing that was missing from it was the internal hard drives. And that's actually how I received that hard drive. And I regard that label as part of its provenance in the same way that I really consider the provenance of paper manuscript. So I'm not an archivist by training, so when I began I had to really look into the subject and think about how curators and scholars really think about archives. And the 3 key things I want to stress was authenticity and provenance, confidentiality. You have to be very sensitive about privacy issues. And then I was also very keen on maintaining the look and style of digital objects. Some people just mentioned the possibility of just keeping the text and not worrying about how it looks. Of course, when you start to think about digital objects, it's very clear very quickly that it's just not feasible. There are many that require you to preserve the look and feel. And so that's how we got into digital forensics, because they have a number of principles, but 2 of the key ones are that you must not change anything that you're examining, and you must be able to demonstrate that you haven't. And what's more, they have a community that is very concerned with testing to make sure that the software behaves as it should, as best as possible, and they have to defend it in court. So that gave us a certain degree of confidence. Actually, forensics has been closely related to archives since time immemorial, even since classic science. So there is a continuity as well. And so we got hold of lots of different forensic software and explored different kinds, both open source and commercial. And we also obtained some hardware from forensic companies, mainly because some of the closest in requirements that can be quite hard, and they're also just used to dealing with forensic software in the same conversation, so it was quite handy to go to them. But the main bit of hardware are write blockers. These prevent your examination computer from writing, changing anything in the collection media of the hard drive, for example. You can have software write blockers, but it's generally regarded that hardware write blockers are more reliable. And so, of course, you're very conscious that if you turn a computer on, the operating system will start to change things, including dates and times. And so you never turn on the original computer. That's not quite true, but that's the idea. And we take the disk out of the original computer, and then we attach it to our examination computer with a write blocker and do a forensic disk image, which is, I'm sure you all know, a single file that represents everything on the disk. And then we work with that disk image file, and you can export exact replicas of the original digital objects residing on the disk, and then we can convert those for preservation reasons into more future-proof, hopefully, file formats and that kind of thing. So I think what I'll do now is very quickly go through the whole life cycle. It's remarkable how much it tallies with the archival life cycle. So we go and do a site visit, we look at what computers they've got, and as part of enhanced curation, we're now doing photography, including high-resolution panoramas of that place. And we've done a few for sound design writing. And they're actually interactive, 360 degree, you can zoom in. And then having got the disk, we like to do this forensic capture twice so that we can be sure we get the same hash values and digital fingerprints for each digital object on the disk as well as the entire disk. And then, unlike with paper where you could just leave it on a shelf for 100 years, we have to process, we have to set up a system that processes the things right from the word going. And we take pictures of all the computer media, in part because there are there's metadata on the outside which you may not actually find internally in digital form. And also, we don't like to put labels on them, and so it means that if it gets separated from its envelope, we can put them back together again. And although we haven't done very much in this direction, we are thinking about how we might acquire people's archives or significant portions of it over the internet, but using a forensically sound method. And obviously that would save a lot in travel time and allow us to capture more from more people. So this is a screenshot from one of the main bits of software, and you can see the hash values on the right. And if you scroll along, you can see the date of creation, the date of last modification, lots of metadata, up to something like 50 kinds of metadata. Usually not from one particular digital object, but potentially there. And you can also you can use those hash values to filter out the operating system. So when you do a search, you use a known hash library which can tell the search engine that these are not relevant because they're identical to operating system files. There's lots of file viewing functionality. And you can also export the digital objects and treat them as digital replicates. And then convert those replicates into what I call digital facsimiles, have the advantage of being modern and more future-proof, but we also keep the original replicate files because those are the ones we can use in emulators and that kind of thing. So there we are exporting. This is a rather simple digital object, it's just part of a data set. And we can also extract the metadata and import that into a cataloguing system. And then we can do search. This is useful, for example, if you want to find credit card numbers and bookmark certain objects as obviously private and not to be made public. And we're also exploring a new kind of hashing called fuzzy hashing, which allows you to find related files. So you can look for, identify a file and ask, are there any related files, similar files in that disk? And it's quite useful if you have a writer who's got lots of drafts and gives a measure of similarity, and you can see if the drafts progressively get more and more similar to the one that you've identified. So it's quite a convenient way to be sure that you're not just getting lots and lots of very, very similar drafts, almost identical, and then one that's very different. You can get a nice progression of similarity. And then it also keeps a log of what you've done, and although we haven't done it very rigorously, there is the potential to really make it a very rigorous audit system that keeps tabs of what you as an examiner are doing. For example, there might be an agreement not to look at deleted files, that kind of thing. And then this is just one version of Excel. We're also interested in visualization, and we're starting to look at that. The top graph is the main one, so it's from one of Bill Hamilton's disks, and I've just taken all the files in it and removed the date. And so this is the time of day that the files were last modified. And you can see that, and I actually happen to know that he used to get up at about 6 o'clock in the morning, and then he would work at home, and then in the afternoon he would go to the university, get on his bicycle, go to the university and work at the university. And you can see this peak of saving happening at my lunchtime. I haven't looked at it in great depth, and you also have to remember it was a family computer, although he was the main user. And you can see there's a bit more activity in the evening. And then these are emails that was sent to Wendy Cope. So it's people in general emailing Wendy Cope, and this is the time of submission. And again, you can see the dip in the middle, which is probably the lunch break. At least that's how I interpret it. I'm now briefly going to what I call ancestral computing. Actually, I use the word ancestral computing partly because I want to distinguish from vintage computing and classic computing in the sense that we're really concerned with all computers, not just the most interesting ones or the most iconic ones. So I've mentioned paper tape before. We had Hewlett-Packard program cards, 8-inch, 5.8 floppy disks. And we also get lots of printouts, which is quite interesting. And I don't think I really need to tell this audience that in the 80s there were very many file formats, and it's really, in a way, Microsoft did us a favour by making things a bit more uniform in some respects, not necessarily every respect, but at least the diversity from our point of view is reduced later. And I have one document where there's 12 more pages of different disk formats. So this is just the formats of the actual disk, it's not the file. So of course this is one approach with the Computer Conservation Society, of course, taking it seriously in terms of other computers. But we've also looked at more modern media devices which will allow us to connect the drive to a modern computer. And actually some early work was done in the late 80s and 90s to service publishers, because publishers were receiving lots of different kinds from writers, and they needed to convert them into an in-house standard. And so there was a market, and Intermedia, which was a UK company, used to offer this equipment for converting 8-inch floppy disk and 5.25-inch 3-inch. And we actually got one of the last ones that is still working. But there's a French company that produces disk to FDI, which is another approach. And then there's Cat Weasel on the bottom left. But the one we're really using the most now, I think, is the CryoFlex. Just because it's very convenient, it connects with a USB to a modern computer, and you can use it with 5.25-inch, 3.5-inch, and 8-inch floppy disk. And it also has some visualization. These aren't my visualizations; it's from the company itself. Top right is a healthy formatted disk. Bottom left is an unformatted disk, and bottom right is a degraded disk. And it's actually quite useful because sometimes you actually don't know, it's not immediately obvious why you can't read them. And now, as you know, there's lots of emulation projects, both by enthusiasts and by professionals, and we are using that. But one thing I thought I would mention is this software called virtual forensic computing. It's essentially designed to make life a bit easier for forensic scientists. It looks at the disk image and tries to work out what kind of virtual machine is required, and configures a suitable machine that can then read the disk image. So in this case, using a internal hard drive from Maynard Smith, the one I showed you earlier, I've asked it to look, and it finds it's Windows 98, and makes a suitable virtual machine, and then I can boot it up in that virtual machine on a modern computer. And I can open up the original applications, and using the original application software that's sitting on that disk. And similarly with Word. One interesting thing about this is the scale of the Word is 150%, and I have wondered, because it was actually slightly poorly cited, and I have wondered if that's a reflection of his need to have it slightly enlarged, and in a way, I find that quite evocative. It's part of his personality coming to use, from that emulation. And then we can shut it down. And then repeating the process with one of Hamilton's disks. You can boot it up again in Mac OS 8. Every time you boot it up, you get a different desktop picture. He's personally taken photographs of the Amazon where he used to do his quite a bit of his research. But one of the most wonderful things is that I was able to run CodeRoller, which was a C++ software on his computer, and you could actually run it and run the programs. And it also means you could, another scientist could change the parameters in the program and perhaps use it in new ways. Which means it's not only about the history. And then one day I actually forgot to turn it off, and up popped the screensaver. And there are scholars who are really very, very interested in that, in in digital humanities, they like that. It's not for every scholar, but other scholars just want to focus on the textual content or whatever, but there are some that are very interested indeed in emulation and look and feel. And then to close, how much time have I got? To close, I thought I would mention a bit of phylogenetic, because that's actually my background, it was in evolutionary biology, and I became very interested that there are humanities researchers who have started to use phylogenetic methods to examine literary texts. And this is on the right, you can see some analysis done with Chaucer's Canterbury Tales. And there are about 80 or so manuscripts that still, of oldish manuscripts that still exist, and they used phylogenetic methods to try and look at which ones were the most ancestral and how they were related to each other, and it matched pretty well what scholars had thought. And again, in computer viruses have been analyzed using phylogenetic methods, because many of them are very related, and the people who write them simply alter earlier versions. And there is a relationship, I think, between evolutionary biology, historical research, and digital forensics, in that we are interested in trying to reconstruct past events and past objects. And it's based on what has been called a multi-evidential perspective. You take traces of information that exists today, and using that to try to reconstruct the past. And to close, there is a story about Voltaire, about Zadig, and it's actually a very ancient story from the Middle East, and it concerns a person who is able to see traces of horses and other animals, and determine what kind of animal it was. And this actually gets him into trouble because people think he's stolen it, and that's where the story goes. But that notion of using existing traces today to recover past events is actually a very ancient one. And it's fitting that Huxley, who of course was based in this area around here, actually wrote a very interesting paper about reconstruction of past events from information that exists today. Another interesting parallel with phylogenetics is that when you boot a computer up, you actually go through the different developmental stages to some extent. For example, when it first boots up, you're actually going through very early phase of the Microsoft system if you're using Windows. And so there is a sense in which quite old code persists even in modern systems, and I find that also very interesting. And if you want to know more, I'm hoping soon that the Digital Preservation Coalition will release papers about digital forensics and preservation. Thank you very much.
Question. Can I ask a question? I'm doing the microphone. This seems a very temporary job, because I store all my information on PCs at work and at home. None of them have got hard disks in that I use anymore, because I store it all in the cloud.
Mm-hmm. Yeah, well, that is an interesting change. I did actually bet when the Pope emails from the cloud that we were relying on the functionality provided by the service cloud jot it down onto the local computer, because when you was working with the emails up in the cloud, and we had to bring it down, and it was only having got it down to her computer, which actually took a long time, I was then able to apply these kind of methods. So we have got things from the cloud, but there are concerns. A lot of it is to do with licensing and giving the right to do it. But I feel that probably things will change because people will, I think, require the ability to have more access to information, have more right to it. Because there are concerns if you, in your will, so I'd like to put my emails or my Facebook profile and content to another member of the family. It may not actually be legal for the person to go and got it, even if they have a password and they have this will. I mean, the terms and services are changing all the time, so I'm not sure how up to date that is, but it is definitely concerning.
I've got more or less the reverse question to Karen's. I think everybody in this room has got enough hard disks, floppy disks and so on to occupy you for a lifetime. And so what is your threshold for deciding to look at somebody's work at all?
I missed the very beginning.
All of us here in the Conservation Society have boxes and boxes of hard disks, floppy disks. What is the threshold? How do you choose?
I think that's a good question. Actually, that's why I quite like hard drives, because there are not so many of them and you can do it all in one go. And so I'm hoping that it's just a phase, and that yes, I've captured nearly 1,000 floppy disks and that. So it's not something I really enjoy doing. So I'm looking forward to when people are using mostly hard drives. But to answer your question, I think it just depends how important it is.
They're not important.
Well, I'm trying to actually increase our scope, and digital is certainly, in terms of amount of information, you can get more information about someone's life more easily with digital, actually. Preserving it doesn't matter, but even, I think solutions are coming on that side as well.
Thank you.
Shall we say you've got a Word file from, shall we say, 1960? Sorry, 1980. I realise you can sort of find it and so on the image of the hard drive. You can perhaps rerun the version of Word, but I'm not sure about that. In which case, do you have to check it against some printed output? In which case that rather defeats the object of the digital thing in the first place.
Well, that's a very good question, and it is, that's to the bottom of the reliability. I mean, the first step is that having captured it, using forensics, it means at least we feel reasonably sure that that object is the right object and it hasn't been changed. If it matters enough, the look and feel it, and it's not easy to do, then it would depend on, then we would do a research project and work on it. But there is quite a lot of software that will allow you to read quite a lot. It just depends how important it is to a scholar, how if it absolutely matches the look and feel. And one thing about virtual forensic computing is and that software is that it's early days for them, but I'm hoping that it will matter to the forensic community, that it looks exactly like it's supposed to, and so therefore they will do some of the research.
You talked to taking an image of the hard disk. Can you say a bit more about how you handle the deleted disk phase?
Yeah, that's a very good question. We basically always try to do what the donor wants. So in some cases we may not take an entire disk at all. We may do what's called a logical acquisition. So they'll just say, this folder, and this folder. But we still use technology to do it. The other approach we're taking is that we ask if we could take the entire disk, but then they tell us which ones they want not to leave with us, and then we delete those within the disk image, and that way we retain the bootability. We're still working on how to do that deletion truly securely, but so we are exploring it, and now our policies are evolving.
Right. Thank you. Tim.
Right. Oh, that's working. There you go. Good afternoon.
Can I just take the slides ready for you?
Yeah, go and do that. I'm never that fussy about slides because I just sort of wander around and talk usually. Good afternoon. As I've been so kindly introduced, I'm Tim Gollins, I'm Head of Digital Preservation at the National Archives. I was struck listening to Jeremy speak at how two practices that might at a distance appear to be very closely related and operate similarly, because of our two different institutions and because of the way in which the information comes to our two different institutions, we've reached radically different conclusions as to what we need to do. And that's kind of what I wanted to talk to you about today. This concept of parsimonious preservation was developed, I won't claim entirely by me, but on the basis of some research that was being blogged and talked about in about 2008-2009. And it's a re-examination, I suppose, of the traditional view of when information, records, things that would come to a National Archive would become obsolete and difficult to read and difficult to present to our community. I should make it clear, our community is you, the citizenry of the UK, and in fact, not just the UK, but anyone who wants to approach us and look at the records of government. So I'm just going to dance through a few bits of background now about the National Archives as much as anything else, so you can understand where we're coming from, because it's really the shape of our institution and the shape of the material that we see that drives the shape of our digital preservation practice. And that might be, and the shape that we've concluded might be rather shocking and surprising to some of you. And that's partly what I'm here to do, to shock and surprise, I hope. Now, which button do I press? That one? Oh, there we go. So, summary of my talk. And I've got some, I've been traditional in putting on bits of paper because it was easier, but I've no doubt email works perfectly well from this laptop at some point in the future. I've put a couple of links to some critical documents in the presentation, so when you've got access to the presentation, you can do some background reading if you were mad enough to want to do that. So first of all, a brief outline of the National Archives. We'll get to that in a minute. A little bit of conversation about what we see our problem as being, what we see our challenge, and what we see the goals we're attempting to achieve with digital preservation. A little bit of conversation about our response, and then something about the system that, as I was saying to Jeremy earlier on, I'm right in the middle of building at the moment. 18 months into a 3-year project, we are, a group of us are trying to build a new, much larger scale, much more efficient digital preservation infrastructure at the National Archives. And we're discovering why it took the guys before us such a long time to build the last one, if you see what I'm saying. Yeah, we thought, it must be easy, because it's kind of obvious, isn't it? Well, kind of, no, it isn't when you get into it, but, you know, as engineers, I'm sure you've all reached that conclusion a few times. And then a little bit, perhaps if there's time, about the tools and services we offer to the world to help others do digital preservation. So, our public task. We're a government department. We have a very specific set of responsibilities. Our chief executive has kindly summarised several trees worth of policy and complex bureaucracy into a few words. For the government record, the word government is very important in there, in particular. The word record is very important in there. Past and future, we have documents going back to the 10th century, right up to the 21st century. Use and reuse, because we're actually responsible for the regulation that governs the reuse of government information. We're responsible for the regulations that determine the way in which certain data is presented for transparency purposes on government websites. And then we've got these statements about authenticity, which Jeremy's spoken of, available and accessible to all. So, as you can see, when you look at the breadth of our remit, whilst we focus on a particular type of material, a particular source of material, government records and government information, the range which we have to think about as an institution is very, very broad. Now, I use this slide to kind of just illustrate where we are, because I was listening. I didn't unfortunately hear the Radio 4 programme this morning that Melvin Bragg had about Caxton and printing. I wish I had, because it would have been really helpful to be able to refer to it in detail today. Because the way I see where we are in the world at the moment is we are in the middle of a period of significant change. It would be unwise to think that we have reached the end of that change, and it would be unwise to think that, as you all know, that the world is as it was 20, 30, 50 years ago. The way we interact with information, the way information behaves, the way human beings respond to information is changing. And the problem we have with that is we are trying to, as digital preservation experts and digital preservation professionals, we're attempting to predict, in some sense, the way in which people will interact with material that we see now in the future. In a future that is definitionally going to have changed in almost every respect from the world we're in today. Now that is a rather tricky task, okay? And crystal ball gazing is not a good, it doesn't earn you much money, right? If it did, we'd all be billionaires. The person who can read a crystal ball well is the person who makes a fortune. So we have to, I think, be very conservative, very gentle in our approach to digital preservation. And I commend Jeremy's forensic approach precisely because it is that. It makes no assumptions about what's going on. It's almost a least touch approach, and that's of course that's the same principle we apply to paper records. Do first medical thing. First, do no harm, right? Don't touch it. Now, so when we start thinking about our digital records, we need to start thinking about some timelines. We need to start thinking about what we're challenged at the National Archives. Now, I need to frame my conversation with the National Archives all of the time, because the choices we've made are choices that only work for us. And I don't want the impression to be given that this is a blueprint or an approach that would necessarily land well in any other institution. It's because we deal with government records, it's because we have some certainty over the shape of those records. There are some limitations on what we see, quite strong limitations actually, and some limitations on volume of what we see, that we're able to make certain decisions. I'm going to turn the piece of paper over. I hope I haven't forgotten all the things I wrote down earlier to say. Right. So, as the National Archives, I've just mentioned we've got parchments from the 10th century. how long am I expected as head of digital preservation to ensure the survival of a digital document that arrives to me today from a public inquiry? Because that's what invariably happens. Most of the material we're seeing at the moment is coming from inquiries. We're not seeing very much material yet from government departments because of the way the Public Records Act works. There has historically been a 30-year rule and soon to become a 20-year rule, which means that we don't see material as records from government until between 30 and 20 years after it's created. So most of the stuff we're currently seeing is coming from organisations, governmental organisations that shut down after having been very short-lived. And the commonest ones of those are public inquiries or major inquests that are high in the public mind. So how long have I got to keep those things for? Well, of course forever, because our statement says in perpetuity. But we've just established that I can't be a crystal ball gazer because I'm certainly no expert at that, and I don't think any of us are. So we need to finesse that question a little bit. We need to break it down a little bit and say, well, what can I actually achieve? What guarantees can I give about this information that I'm charged with looking after? And so should I keep? So perpetuity is a long time. So is it 1,000 years? No. I don't think anybody in the 10th century would have really had much of a vision of Google. So I think that's a little unreasonable, perhaps. Given change and all that. 100 years. Well, do you think computers and you guys know all about computers. So Babbage was around before the 1900s, wasn't he? But do you think Babbage would have, and Ada Lovelace would have seen Google coming over the horizon, the internet coming over us? I don't think so. The first real mention of anything that looks like the internet is what's his name? It's an article in a magazine in the sort of 1940s, 50s. Sorry? Yeah, it's Vannevar Bush. That's right. I couldn't think of the name. You're quite right. Vannevar Bush and his Memex, which is this magic desk that produces information for him, and that's the closest thing. That's the first real visionary statement that sort of imagines the internet in a way. And that's only 50 years ago. So I'm probably not going to be able to predict 100 years in the future, and I'm probably not even going to manage 50 years. Do you know what? I reckon I'll be lucky if I can do 10 right now. So all of a sudden my keeping things in perpetuity has kind of my practical capability is somewhat reduced. Right? So we'll just stop that thought process for a moment and think about what I might do as an engineer to solve this problem. I need to build a system, right? We handle a lot of data. We have a storage system at the moment that has and I'm choosing my words carefully, a theoretical capacity in excess of 13 petabytes. We haven't actually got even a tiny fraction of data of that size in it yet, but if we were to populate all the tape slots, that's how much we could hold. So I've got to be able to do this at scale. I've got to be able to shovel data around pretty fast. I've got to be able to do it in an automated way. Because this stuff is coming to me in bulk from government, I can't afford to have people inspecting every object. There isn't time for that. We don't have enough budget for that. So this has got to be automated. Right, so I'm now going to build an automated system. How long does the average computer system last in operation today? I reckon, and if you go to a company and you say, when do you write off your computers, they write them off after 5 years, right? Perhaps 7 if they're feeling really mean. They'll sweat the asset for another couple of years, maybe. But certainly they're dead and gone after 10. That's interesting. We've just reached the same number. It's quite a useful observation, that the probable maximum life of my preservation system that I'm halfway through building today is about 10 years. Useful, perhaps. Okay, next question. What data am I actually going to see? Right, I'm going to show you a graph now. This is a graph of the National Archives' own administrative records. Because we're a government department, okay? We have our own administration, so we have our own record-keeping system that keeps the records of the activities of the National Archives as distinct to the records we receive from government and look after. Did I make that clear enough? Good, because it gets a bit confusing if I'm not careful there. This is a plot of the number of files against file format of that system as it stood sometime earlier this year. And because it's hard to read and because of the way Excel plots things, you don't see all the points on the graph. I've put a little table up of the top however many it is, and I stopped at PPTX because that was the file format I was using. But I thought that was a good place to stop, and it kind of fitted on quite nicely. But you'll notice that nearly 60% of the objects on that system are in one format, MSG, email messages. The next block down is .doc, Microsoft Word essentially. 20.6% of the objects are in Microsoft Word. The next point down, we're now down to 6.4%. So we've knocked off, what's that, 60 to 80, nearly 80% of our 80-20 rule, which government people always tell me to apply. Okay, 80-20, I'll just save MSG and doc and throw the rest away. Done my job. Right? Actually, I haven't, of course, because hidden inside the MSG are loads of attachments that then distribute to the rest of the distribution just the same as the distribution that's there anyway. But you see the point. The point is that this distribution is phenomenally skewed. And when we look at the way records are selected to come to the National Archives, 5% of government's output, approximately, eventually makes it into the National Archives. So 95% of government information is considered trivial and ephemeral and not worthy of keeping beyond 5 to 15 years of life. I know, because when I started work at GCHQ, I had to use a paper file, because that's what we had then. That's good, much better than these computer things, much more reliable. There was a nice lady in the room in the corner that had a big filing cabinet that kept them on. Very efficient. 3107/2/3, that was the number of my file. I used to use it all the time, it's great. However, the point is that a very strong selection mechanism takes place before material comes to the National Archives. This is another part of our strength, because actually that selection mechanism is also skewed, and it's skewed in the same direction. It's skewed towards the common formats, because the stuff that we tend to be interested in is policy documents. It tends to be minutes of meetings. It tends to be decisions. It tends to be the things that historians care about with respect to government. What did the Prime Minister write down? What did the Prime Minister say? What did the Prime Minister think on date X in time? What advice did he receive from his civil servants? These tend to be in very, very few formats in practice. So all of a sudden my problem has collapsed from the problem that Jeremy has of any file format from anywhere arriving on a computer that's horrible and oh my god, to probably a few dozen file formats arriving in bulk with some decent metadata around it. That's starting to look like something I can engineer against. That's starting to look like something I can build a system to cope with, which is good because that's what they're doing. I'm going to go back. Can I go back? Yeah, I managed back as well. This is an Apple, you see. I don't use Apple computers, so two keys is the maximum I can cope with. So that's kind of useful. Now let's look at and let's think about another graph. Let's imagine a graph of all the file formats that are available on the internet. Same type of plot. File format on the bottom, frequency going up the side, ordered in frequency, so you get that lovely curve. Guess what? You get exactly the same curve. And guess what? You get really the same formats in the left-hand end. Just the spike's much bigger, and you get some HTML in there coming a bit higher up because you're dealing with the web rather than you're dealing with things. But if you strip out the carrier pages and just look at the standalone documentation on the internet, you get very nearly the same picture. Now we get to a nice economic argument. everybody talks about file format obsolescence. Everybody says that, oh, this software isn't going to be available in such a period of time. And you're right, eventually it won't be. Okay? But remember, my margin is now 10 years. My margin isn't forever. My margin is, can I interpret this material for the next 10 years, and can I pass it on to my successor and their system in good state, knowing what it is and therefore knowing what to do with it. Right. Now I think I can do that because I can look at this and I can look at the internet and I can say, do you know what? Actually, I can still read most Microsoft Word documents perfectly well on my PC at home just by downloading OpenOffice. It's not perfect, you know, but it's 80-20. PDF, I can still read PDF 1 on my new PDF viewer perfectly well. That's been around for a few years. Unix file system still readable 30 years after it was created. If you can get to the Unix, if you can get to a disk that's 30 years old that still works, modern Unix file system will still be read on a modern Linux machine perfectly. Old file system, modern Linux machine perfectly well. So actually, this concept of file format obsolescence that has been talked about and has bedeviled and has sort of hangs like a spectre over the top of the practice of digital preservation is much less common than you might believe. A gentleman called David Rosenthal speaks about this on his blog. If you Google David Rosenthal and have a read of his blog, he speaks much more eloquently than I can about this concept of the fact that file format obsolescence almost never happens, as he puts it. Now, so I'm a government, so I'm a civil servant. I've got to save money. I've got no money because, you know, government cuts and all that jazz. So hence parsimonious. Hence we've got to do the minimum. It's about doing the minimum necessary, the minimum needed that we have evidence to do. It's a scientific method in essence, and that says, okay, what do I have to do to pass my legacy to my successor? Well, I have to know what it is. It's really important that I know what it is. I need to know where it came from. I need some statement about its authenticity. I need to know what file format it's in, because actually that's really important. It is important to know whether I'm dealing with a piece of Microsoft Word or an MPEG-3 or an HTML file. That's vital, because I can't do anything without knowing that. I can't even show it to my customer, to my user, because I need to be able, because remember, I might not have the file extension, I might not have anything, I'm literally just have a bunch of bits. If I don't know what it is, I can't tell them how to read it. And I can't expect them to be capable of working it out. So I have to know that. And then, pretty much all I need to do at that point is, having captured those two facts, and that is, neither of those two things are simple, I should say, but it sounds simple. I then have to keep the bits safe. I have to make sure that the bits I have and I hand over in 10 years' time are the same bits as I got at the beginning. And that's about cryptographic hashing, that's about making sure we've got disaster recovery, making sure we have tape systems, our base level dark storage has diverse media, so we don't get corrupted media. We have multiple copies, about knowing where it is and being able to put it back. So it now turns from this horrible, complex, intellectual digital preservation problem into an information flow, information management, and systems problem. And those are all tractable problems, and that's how we can start to think about building our new digital preservation system. And those are the principles on which our new digital preservation system is based. So the first thing our system does is it establishes whether we're receiving material that we would be surprised at receiving. In other words, if I get a supply of some material from a government department, I ask them to tell me what they're sending me, file format wise, and in terms of where it's come from, whose information it is. First thing I do is check if they lied. Right? Have they sent me the metadata and then sent me a random piece of file system with a load of stuff on it they didn't intend? If they do, I send it back and say, do it again, guys, because actually I need this stuff consistent. I need them to do a cryptographic hash before they send the data. I can't do anything as the National Archive, as the head of digital preservation at National Archives. about the way that information was managed and handled and operated on in the government department. It's not my responsibility. We can advise, and we do advise, but we have no control. What we do have control of is the process by which the information comes to us and what happens to it once we've got it. And actually, when you think about even the paper record, nothing's changed. Because sometimes people say to me, oh, but aren't digital files easier to fake? Well, yes and no. Yes, as Jeremy pointed out, forgery in the archives is a very, very long tradition. In fact, there are entire academic studies of the forgery of medieval charters. Who forged them? Why they forged them? What was the benefit of forging them? We've had forgeries in our collection. They've been published. There's articles in The Guardian about it. And that was paper. And it was hard to spot. And at first we didn't believe it had been done. Now the thing about those forgeries, the ones that we that have been publicised in our collection, they were perpetrated through our reading rooms. So somebody came in, accessed the file, and because we give them the original file to read, they were able to insert and modify material on that file. In the digital world, that can't happen. Because I've got the original file, I've got it in my dark archive, I've got a cryptographic hash of it. If somebody claims they've got a new one, I can simply say, touch me, you haven't, I've got the original here, it's got the cryptographic hash, there's no way that that's the original object. So actually, it's quite hard for a reader, in fact I would claim it's almost impossible for a reader to forge a digital document and assert that it came from the National Archives as an official document, as an official record. So let's look at the other place where it might happen. It might happen upstream, it might happen in the government department. And everyone has this assumption, oh, everybody wants to do a cover-up, right? So, what's going to happen at the government department? Well, yes, actually, it could happen there. And I couldn't detect it, you couldn't detect it. In fact, nobody could probably detect it. But think about the way the paper system worked. If I wanted to fake a letter and when I worked at GCHQ, all I'd have to do was write it, stick it on the file. Nobody would know. I could put anything in there. 20 years, somebody comes along and has a look at it, oh, look at that amazing thing that was said at GCHQ. So, in a sense, nothing's changed. We're back on we fall back on the trust in the institution and the trust in their processes. Am I nearly out of time? 5 minutes. We fall back on the trust in the institution and the trust in its processes. Now, one of the things that my chief executive talks about, because one of the questions that we get asked is about trusted digital repositories. Actually, if I were to, we did this with I'll tell you a very short brief here. We've just digitised a set of rather interesting documents. They're the records of the Home Guard from the County of Durham. Every member of the Home Guard in the County of Durham had a personnel file. It consisted of about 3 or 4 sheets of paper on a standardised form. And we've digitised them and we've put them online. And we don't expect that the original paper will survive. What we expect to happen, we have not accessioned, we've not brought into the National Archives the paper. We've chosen to treat as the official record the digital objects that we have created. Okay? What the MOD choose to do with the original material will be up to them, but I would observe it costs them to keep it and they haven't got much money. Okay. So we started off thinking we needed to do an awful lot of things to demonstrate that this picture that we'd taken of this piece of paper was authentic. Okay. So we decided to record all the processes we did, and we recorded them using a standard, a provenance standard of XML that's been developed. And we've got this for every single image of this collection of 80,000 records from the Durham Home Guard. Now, my father wasn't in the Home Guard, he did his national service just after the war, but let's just imagine he was in the Home Guard, let's just imagine he was in Durham. and I choose to look at his record, and I look at it and say, that's not about my fault, that cannot be true, right? They faked it. Okay? The National Archives has faked my dad's Home Guard record. Okay, what are we going to do? I'm going to send them this pile of XML that says, look, no, we did all these things. Is that going to change anything? Is that because in essence, they've accused me as an institution of doing some wrong. And I'm going to provide them with some computer data that's an XML file that says, no, I didn't. Proves nothing. Proves absolutely nothing. Now, okay, it might prove that in general we did some due diligence and that in general we did the right thing in the way in which we treated those records. But I don't need to keep 80,000 different ones of those to show that I did that. I actually need to keep a lot less than that. So the trust isn't demonstrated by going through having little bits of data. Yes, the cryptographic hash is helpful because it tells me that nothing changed in the image from when the cameras took it to when it got to me. But again, that's not going to help. You know, if I'm disputing the content of the record, that's an unimaginable sort of thing. I mean, if the handwriting's wrong or the words are wrong, that's not going to be because I faked up the image. It doesn't work. You know, the world doesn't work like that. So it boils down to the fact that, terribly sorry, but in the Public Records Act, it says quite unequivocally, if the keeper of the public record provides you with a copy of a record, that is the record. And that is evidence in court that the court can't directly challenge. And that's where we are. In other words, trust us, because you've got to. and this is an important thing to understand about the way in which the digital works. Digital is no more trustworthy or less trustworthy than paper. In the end, it relies on the institution demonstrating its trustworthiness through maintaining its reputation. If it has a reputation of being trustworthy, it will be trusted. If it does not, it doesn't matter what measures it takes in terms of pumping out bits of XML or jumping through hoops or signing certificates, it won't be trusted. And its data won't be trusted. I've drifted all over the place, I tend to do this. So, what's parsimonious preservation? To wrap up, know what you've got, keep the bits safe, and that's it. Thank you. And if anyone's got any questions, happily.
Am I right in thinking?
I'm going to let my microphone man decide who's speaking first, if that's okay with you.
Brian Sport. Do you ever come across any records that you can't recover? This is possibly a question for Jeremy as well, because I've read in the past that in America, specifically, they've got lots of records on old computer tapes where the formats, etc., have long been lost. And whilst
or the media they've degraded, in fact.
Well, I wasn't saying so much as degrading, they've just forgotten how to be able to read them.
Yeah, the answer is no, but. And the but is that if the government department can't read the data, we won't try. Our rules say it's in the custody of the government department. If the government department has not kept it competently, then they are at fault and they have to fix it, and do what they need to do to fix it, and then transfer it to us. There's a very clear handoff of responsibility for that information. And also, because of the way selection works, and because of the way the Public Records Act worked, and because of the way the regulations worked over the periods we're talking about, the reality is that whilst computers were used strongly in government from from 60s, 70s and 80s, in practice, material that constitutes a public record, most of it wasn't put and held ubiquitously on computers until we get into the 21st century. So the actual incidence of material like that is it doesn't actually happen.
Thank you.
Am I right in thinking that the county archives aren't your responsibility?
They're not complete. No, they're not our responsibility as such. Although we do now have the amazing position of being called the archive sector leaders.
Oh,
And I don't know what that means because it's not part of my job. But I think it means we tell them what they should do, but don't give them any money to do it.
Oh, I see. Well, could you tell the Surrey History Centre that they should be able to accept records in digital format?
I would love to tell them that, although the reality, I'm afraid, is that most of our local archives and local history people simply don't have either the people or the resources at the moment to take digital material. There are a few counties that have developed that capability, but it's very patchy, and it's something that, as archive sector leaders, to quote, we are working to change. But they've got no money. You tend to be working with an archivist who was trained 20 years ago and is probably quite good at medieval paleography, but Linux probably stretches them a bit.
Go on.
Yeah, I realise you probably simplified to a great extent what you actually do, but
yes.
it sounded a bit like your strategy was kind of passing the buck of difficult stuff onto your successor.
Yes, absolutely.
In particular, to give an example, one of your popular file formats was PDF, and that's a proprietary format.
It is.
Are you taking steps now to make sure that specifications for these proprietary file formats are put on record so that your successor doesn't then have the problem of trying to reverse engineer, emulate, or, you can imagine those problems are going to get
you're quite right. The answer to that is strictly no, I'm not. But that's not because I don't think it should be done. It's because I think in practice it is being done, and it's being done all over the place. And if in practice you want to find a spec for PDF, it's not very hard.
XPDF.
Sorry?
The XPDF.
Yeah.
Really looks up.
Exactly. So in practice, it would be a waste of my resource to do that. And this is one of the other things we've discovered recently. I didn't get on to talk about the tools that we offer. We have two services. We have a thing called Pronom, which lists file formats. We have a thing called Droid, which identifies file formats based on binary signatures that we store in the Pronom database. We create ourselves. So we identify the file format, but when they first created Pronom, we thought it would be a really good idea to curate the information about the file format and keep it in this database. We discovered that this was the most huge and enormous task that was probably beyond the capabilities of the organisation as a whole, let alone the one person whose job it was to put data into Pronom. Okay? Because that's what we're talking about. We're talking about one person. Okay? Because that's the way that it works. In practice, you go to Wikipedia. In practice, you go to the XPDF open source code base. You go to Git. You go to where a community of people are actually doing this stuff for you. Now, okay, it's not authoritative, but actually it's probably right. And at the end of the day, that's all you care about. So the answer is really no. I'm also not passing the buck, because I believe that the economic environment will do a whole load of things that it would be uneconomic for me to do, and that I can rely on that being there in 10 years' time. We can debate that and dispute that, I agree, but that's the position that we are operating at the moment.
I'm wondering a little about your 10 years. I know you were being a little cynical when you were using the term.
I am. I'm waving my arms very broadly here, you understand.
Well, in passing I'll mention the word Hillsborough.
Yes, indeed. A very good point, sir. Extremely good point.
But the one that I was thinking of is Swansea Joke Factory, DVLA, started in the mid-60s.
Indeed.
I would reckon in that time it's been through probably 8 to 10 lots of hardware.
Absolutely.
But it's probably only been through about 3 lots of basic software design in that time.
That's probably true. There's a big line of business systems that operate like that.
and information right from the earliest days might be required for somebody.
It might be, and it will be, because in the particular case of the example you cite, it's in their business, part of their business requirements to migrate that data out of the old system into the new, to maintain its availability. That's not quite the same as my task as a public record in the National Archives of Digital Preservation. That's about something that we've dubbed digital continuity, to try and distinguish it, which is about keeping data that is critical for the operation of a business active within the business for the length of time it needs to be. And that's actually, again, not a special game, not a special thing. That's just good business management. That's about saying, what are the outcomes that this system has to achieve? Do you know what? It has to pass its data on to the future. And so, yes, I think the answer is yes and no. The other thing to say is that the sort of data you're talking about doesn't come to us. It's in the 95% that never makes it to the National Archives, because it's personal data and it's what's called case data. It's about individual case histories, and that is rarely recorded at the National Archives.
I think we can possibly move on. We're already half an hour late. But there's time.
Nothing new there.
Okay.
Thank you, Joe.
Hello everybody. In the interests of not taking too long, let's move straight from me and look at the past. Now, I'm talking from the context of preserving software that's related to the CCS's activities. And the truth of the matter is that there are all sorts of things that I haven't done in the past 10 years that I realised I should have done as I was preparing this talk. The fact that we've lost lots of stuff from the 1950s indicates that I am not alone in that. And so the bits that do remain, I'm very keen to collect up. I'm very much with Tim, the previous speaker, that it's keeping the bits that matters. Once you keep the bits, then you can always go back and look at them again. Bits, I realise they're slightly different bits. From the 1960s, we do have bits of software, but we don't yet have what we would really call a complete system. George 3 survives, and I have ambitions to prove that to you later. So that's the 70 system. And the BBC Micro, there are more emulators of the BBC Micro than there were BBC Micros made. Well, that's not quite true, but there are quite a lot. What about the 90s and the 2000s? Are they yet history? And I remember there was something called GEM, you know, in the day, just as Windows were beginning. It would be quite nice to have a copy of that now. Just out of curiosity. So it's just so easy to lose stuff, and it's at that early stage when you lose it. Once we've actually taken serious attempts to keep it, it's really quite easy to keep it forever. For the future, we are told to address, well, who is the future? Who, historians, IT professionals, and just Joe public, the hoi polloi, I think are people we need to address. I talk about nostalgia versus history because most of what I've done has sort of been in nostalgia vein, in that the only people who've actually seen the results are people who remember the original. And the big challenge in this is to make this stuff comprehensible to people who never saw the original. And what do they want to see? Well, they want to see what computing was like in the past. And of course, don't forget, our present will become the past. Source code, because I think it's quite interesting to see the software engineering of yesteryear. It can be a bit salutary sometimes, especially when it's your own. But I have had my own decades-old code come back to me. Support documentation is something else they would perhaps like to see, and again, that might be just as difficult. And they'd like to see it running, I think, and that's mainly where I've focused preservation activity. Now, what I'm going to show you now is that who the future is or might be. Now, this is a picture, and it's going to be engraved on a geosynchronous satellite that's going to be launched quite soon, because the idea is that the geosynchronous satellites will actually outlive humanity, because they'll sit up there, and long after we've fizzled out, they'll still be there. And so this guy, Trevor Padding, has this idea of engraving them onto this satellite, because they'll outlive human civilization. A colleague of mine, Paul Wheatley, coined a nice phrase: we have no faith in long-lived media. You probably know Paul. Yes. And he now works at the British Library. For the future. Now, what's the future in terms of hardware? Well, it might be Windows 99, but I doubt it somehow. A colleague of mine years ago said, I don't know what programming language I'll be using in the year 2000, but I know it's called Fortran. Well, it turned out that even the names changed. And Wintel is not immortal. Screens and keyboards, hard or soft. Now, somehow I don't have enough clairvoyance to see the end of that. But it will come sometime, I guess. Once certain, it's uncertain. In that film, the Best Exotic Marigold Hotel, there's one bit where I think Judi Dench's character says, the one thing we can be certain about the future, it will be different. And we've got to go beyond nostalgia. We must treat the future generations. Maybe video might be the best medium for some of our stuff. And hot metal documentation is a problem that I'll grumble about in a few minutes. Now, clearly we need access to stuff we've preserved. We want to present the preserved information in a meaningful way. That's clearly what you guys at National Archives have to do. But the change of the presentation medium over time is guaranteed. And if you get preservation wrong, you probably can't go back. If you didn't keep it in the first place, or you didn't remember the format in the first place, you can't go back. Certainly if you didn't keep it, you can't go back. And I suffer from the fact of some printer listings I would really like to have were discarded by a university library that was given them for preservation. Don't think paper is long-lived, it isn't. Yeah, remember not to throw it away. So I've worked on getting the raw bits from the original media while you can still read it. Stored in files on current systems. Original media are only valid as museum exhibits. That's all. That doesn't mean it's not worth keeping one or two, but you don't need them all. You keep this stuff as the archival form. And a test that I think we should always apply. Could we reproduce the original object from our preserved files if the hardware existed? You know, hypothesize that you can still write 3.5-inch floppy disks. And could you reproduce it? And in particular, could you reproduce the significant properties? Because a 3.5-inch disk with the files in exactly the same places as they were originally is probably not got any more value than another copy of the same information. But if you can do that, we've lost nothing. Our general strategy then is the original byte streams, and I think bytes are going to be with us for some years. Somehow they've overtaken things. I will keep them in a long line archive, and they can easily be downloaded, stored in modern files. We can stick it on a web server, and we should develop or acquire software which provides the meaningful access. And then that gives us access to the intellectual content, it allows us to repeat the experience in the original, and of course you can easily deliver it from a web server. And then we find 2 or 3 long-lived institutions who will keep preserved objects forever and for free. And there's a list of candidates. Now, the CCS doesn't quite have such a relationship yet, but I feel we should try and get it. And it's important about it being free, because if it isn't free, some clowns later on will decide to chop the recurrent payments to keep it kept. And when that happens, it will have to happen once, and you're back to this problem that you've lost the archival copy, and you're screwed. You can never go back. Long-term maintenance, well, just copy the originals unmodified. That's pretty cheap. Yeah. Especially as the new media will be a lot cheaper than the old one. And you update the access tools to track the technology. I resist temptation. I do think there's been a tendency for access opportunities to distort the preservation of the raw digital object. Work we did back at Leeds with the BBC Doomsday data, I can see that some of the way we did things related to the opportunities of the time. But the original suffered from that even more. They thought they were preserving all this stuff for yonks, and they actually did it in a way that was trying to exploit the laser vision technology, and it actually completely undermined the preservability. Avoid reversible transformations on your preserved object. If you really can't resist the temptation to change the format, make sure it's one from which you can change back to the original. Avoid being seduced by today's fashionable gizmos, because our ambitions focus on tomorrow plus plus. That means and after. This business of handing on to your successor. In fact, I think the Curation Centre still has my chapter on preservation strategies, which actually contains that recommendation. So I'm writing on implementing meaningful access capabilities while the originators are alive, and then preserve the access tools alongside the archived objects, but not among them, and imagine the mindset of those who never saw the originators. So that's what I'm trying to do with preserving. Now then, here's a contentious issue. It's going to involve writing software. The idea is to choose languages with a view to long-term availability. Well, the stuff that survived best is written in C. Make files are a no-no. I'll explain a bit more as to why I'm saying that later. So we should code with portability in mind. Now, part of what I know I've said primarily I focus on execution, but source text is also important. Looking at source text and being able to read it. Now, from the 1970s onwards, that was all byte-oriented. But we had lots and lots of character codes. As somebody once said, standards are really good things. Aren't we fortunate to have so many of them? But it's easy to store the old stuff in modern files. Paper tapes, cards and stuff like that. Well, I moved on to the idea that we should map the bits, i.e. the holes, into bytes in files. Because there are some examples of which KDF9, where I've worked, is a case in point, where converting it into ISO, ASCII, or whatever you want to call it, actually loses information, so you can't go back to the original. Anything with shift characters in is a problem in that direction. So again, I'll come back to this criterion. Can you reproduce the original from your preserved files if the hardware exists? Let's look at some human-readable text. You want to make it look like the original. We've preserved all these bits, but frankly, if you don't look like the original, it probably can't read it at all. The historic character codes actually go beyond ISO Latin 1, and I think probably even Unicode. You get all sorts of quirky things in, ancient things from yesteryear. And at the same time, if we're into emulation, we actually need to be able to deliver the same bits into the emulating software that the software was written to read. In other words, if you're reading emulated 5-hole paper tape, it needs to look like 5-hole paper tape looked 20, 30 years ago. So, for looking at the stuff for humans, I reckon converting to HTML is as good as anything, because HTML allows you to manufacture all sorts of squiggles on the screen. But this is for display, not for archival. It works very well for KDF9, though recently I've been poking about with Atlas type things, and they're actually characters which are made by overstripes. You know, you equal backspace slash, and that's not equal. But there's a bit of KDF9 Fletcher writer. It's stuff off. And those of you who remember KDF9, that looks like it looked on the Fletcher writer. It's got line counts down the side which weren't on the original, because you see the fact of the matter is that when you put this through the LDOL compiler that we've got working, it assumed you were going to count your lines on the line printer list, so it didn't bother with the blanks. So you need a count without the blanks in it. But look, you've got all the underlines, the underlined square brackets, there's the KDF9 multiply sign, and the little arrow end message, and that's all pure unadulterated HTML. Execution, again you want it to look like the original. So you've got to substitute the hardware. Teletypes are actually quite difficult to acquire these days, as are paper tape readers. In fact, I made a big mistake of throwing a paper tape reader away because it was very ugly, and it lived in my study, and my study is sort of semi-detached from our bedroom, and it got a lot of flack from the cohabitee of the bedroom. It's been recycled, but other people could read paper tape. So the execution scheme is to emulate all the hardware. The process is actually quite easy with perfect documentation. Hands up those who've got perfect documentation. And that's one of the reasons I'm very keen to try and get something working within the lifetime of people who knew the original. Because you sometimes have to turn to those people to find little snippets of information that are vital to make it work. A disk drive is very easily emulated as a binary file. A teletype, well, a keyboard, a screen and window, it doesn't produce quite the same noise or the same sort of ambience as a real teletype, but that might be a good thing. Where are we now? Well, raw data, we've got various bits of stuff, and that's only an example. We've got reconstituted data. In the last few years, we've done some work with printer listings and been amazingly successful, I think, in turning them back into executing code. You know, real assembly language stuff. Hundreds of pages. And we've got it working. Western Aldo, Brian Richmond will testify. We've got it working. Support software, well, we've got multiple emulators by various authors. Let's be honest, we've got multiple versions of multiple emulators by the various authors. So I'm trying to future-proof the raw data by copying files onto new systems. And I think we need to do this now. You perhaps remember Rod's bit on Radio 4 about Flossie, which I thought was very good one. And we hear that it might well have to move. I do hope we get all the software that is around it into modern hardware that we can keep forever. Because devices to read old media don't last forever. The laser discs from the BBC Doomsday Project are probably perfect still, but the laser vision players are a load of overrated. Back to the future. Emulate all the hardware. The central processor is easy. The disk drive is binary file. That the magnetic tape was an interesting one because it got the concept of block structure. And the format we've used just has markers. Well, basically, you write a block into the file with the header to say how big it is, and basically it's kind of packet switch. Now, what about the screen? Well, The nearest thing I can find for an API for a screen that we can use in writing emulators that will last for a long time, I thought the Java Abstract Window Toolkit was probably good. And I actually wrote a little teletype emulator. Admittedly, it's not a very big and sophisticated program. And it emulated the teletype really rather well. I ran it on my Windows 98 machine, it worked fine. I ran it on my Ubuntu machine and it worked fine on that. And put it on Kevin's machine here. And there's something wrong with the focus and it doesn't work. So even what seemed to be a good candidate when I did the slides is a good outro.
Talk about BNC, Dave. Think about BNC. Real BNC.
Did you what? Sorry,
Think about real BNC for screen emulation.
No, I didn't. No, as I said, I knocked out the teletype emulator, just as a quickie, having had the idea that Java AWT would be a good medium. Right? But some of our emulators are very old, some are pre-Windows. I did a checkout on modern systems through all the things that are on the website. The C source code survives surprisingly well. Now, I looked at what rain check really meant, and it isn't quite the same to go back and check again, but it's we've been able to go to a baseball match that's been cancelled in the rain and then start again. So I went back and looked at our emulators, and you see, I don't have much by way of Windows stuff, so I borrowed somebody's Windows 7x64 system. And the George 3 emulation we've got, the KDFL emulation we've got, and the BBC Micro emulation all work straight out the box, but not the old ones. So then I went back to source code and ran it on GNU Linux, which I've got a much more modern version of, and Raspberry Pi. Most of the C worked. Even the EDSAC emulator, which I thought was quite a nice touch, the one emulating the very oldest machine of all, is the one that worked. The Ada and the Pascal systems failed to compile, not sort of irrevocably failed to compile, but they didn't work out the shrink wrap box. So our George 3 system, now I'm planning to show you it working. I took the C source code from 2003, recompiled it for the Raspberry Pi, which is an ARM chip, not Intel. And I took the Java class file, unload file from 2003, and that just worked. George 3's hardware looked a lot like that. Can you look how cheap computer Ruby was? And that's all the bits. You see the tape drive in the back, the operating console. So when we move to modern hardware, it looks a bit like that. Now, I know that looks quite big, but that's the RJ45 connector, you know. And in fact, the very one is here. That's it. And it runs George 3. Including the disk drives, the operator's console is it rubbish. So that was that. Look, we'll come back to that. I've got another copy of that on the end. We won't try and do it now because there was one or two minor incidents which involved unplugging something and something else. And if it doesn't work, I don't want to get distracted from what we're trying to really talk about. But at the end, and if you really want to stick around for just a few minutes, you can get your smartphone out, get your teletype emulator on your smartphone, and you can log on to them. So I'm talking about subset C, banning macros, union, address arithmetic, non-Boolean conditions, and embedded assignments, which I'm big to using a lot of stuff, and variadic functions. Now that is a bit of a restriction, but it's kind of the intersection of C and Java. And it's interesting that I wrote a paper making this recommendation over 10 years ago, and it still gets the odd citation, because one copy of the 600 University of Michigan website, for some reason they changed the name of their website. Nostalgia and history, well, we've always had first-hand experience, people doing it. And some of our emulators are only meaningful to people with first-hand experience. And George still one like that. Well, that wasn't supposed to match yet, never mind. Edinburgh, look, I've changed that to black more times than I can remember. You see, that's a format compatibility problem, see, because this was produced on OpenOffice and it's now being shown on the Mac. But Edinburgh archived their implementation of actual source code, which they did on KDF9 as part of their migration WIN, which is developed from actual source code, which they ran on System 4. And it's a really nice looking piece of software. And they preserved it in their archive. It's like exact service not actually working with it. But they did probably should come back. And there was source text and some documentation. And I was really getting enthused. And there's a group of us communicating by email. And I sent an email and I said, where is the binary program? And where came back the answer? Now, of course, I'm nothing's not overconfident. It's a self-compiling compiler. So therefore, all the information you need is in there. Right? So it should be possible to recreate the binary. All you've got to do is execute the self-compiling compiler once, and it will generate the thing you want. And all you need to do that is the thing that you want. Well, that's my outsider's experience. I've got good personal familiarity with KDF9, as people here can testify. But I've no personal familiarity with Atlas or Atlas Ultimate. I've only seen an Atlas once in my life. Now, I spent quite a lot of time on it. Because I'm using it as a way where I'm trying to do digital preservation and emulation in an environment in which I'm not familiar with the material that I'm working with. You see, so I'm trying to look at what it's like in the distant future. And I'm actually finding it rather difficult. I think I've got the first half of it done, but until I get the other half done, I can't really find out whether the first half's going to work or not. So it means I should redouble efforts to make it intelligible to people in the future who didn't know the original. So here's some things here's some New Year resolutions for me. I'm going to get a copy of the software on all the CCS's preserved machines. I should have done it, John, so I'll make it available for download. And we'll make some facilities for viewing source code that we've got in its original form, and emulators where they don't exist already. And people want to volunteer to join in on this ambition, I'll be most keen to hear from. And update existing emulators to make them more future-proof. An unsolved problem, I think, is hot metal documentation. In the 70s, 60s sort of time, basically manuals were printed pieces of paper, books. Now, you might think that's quite, but that's only one of the manuals for George 3. That's the operation management manual. Well, a surprisingly healthy looking copy. But it's not the user's manual, it's just as fat. I do have a document written for Leeds University users, and I have that electronically, which is on the website, along with George 3. What about copyright? Well, that's another unsolved problem. Now, have you come across the aggressive rescue? I was introduced to this by a lady called Anne Van Camp from ROG in California. And she said, look, copy it, keep quiet, it'll go out of copyright eventually. I'm serious, we're actually talking about keeping things, beyond copyright. Copyright was originally introduced not for the benefit of the authors, but to try and make sure that material didn't get lost. That's what I've been told by historians, right? It's been purloined, hijacked by authors to try and keep this, to improve their income. And I think we can make export copies on modern media, because the problem is, by the time copyright has actually expired, we won't be able to read it. And the copyright legislation is just not really suitable for a digital world, but I can't wait for the lawyers to solve all the problems. And if need be, we should publicise non-availability. This material is not available for copyright reasons. Sometimes that can sway people to change their mind. It's bad for the brand. If in doubt, keep it. It's small enough, it gets smaller and smaller. Honest. Don't forget, digital material gets smaller as time passes. The jacket's over there. I just bought a 4 gigabyte SD card this morning, and that's only because they didn't have any 8s in the shop. Yeah, you know what SD cards are like. I mean, seriously, it gets smaller and smaller and smaller. And it comes perfect. And you use MD5 and things like that if you really care about people shooting on you. But I'm not liking the sorry, I don't have National Archives type ambitions. So that's the ambition. Software tools to do emulated viewers. And I think we should make stuff available with the public license. And all downloadable from web servers. That's me. And that's a website which I keep as a kind of work in progress place for software conservation activities. Anybody's welcome to up there. And you can pick up things and you can download the geometry emulation. But the source text isn't there. So I was going to work with Delvin, who's a co-author sitting at the back there, and say we should put it on GPL and just publicise it for you free.
Yeah,
you don't have to
it's
decide.
always you. We don't want to have a debate about it, don't forever, but I'm pushing towards the BSD license or the Apache license, so you'll find you have far fewer problems with any of the software vendors. I say that as a man who worked for Microsoft, actually give software to universities and give software to universities. BSD was easy as long as it got like that.
Well, I'll come back to you on that, but based, I might.
I think one of the licenses requires that everything has a license. You have to license anything that uses it using the same license.
You this bar and affects everything else in your organisation, which is why companies get upset.
Well, no, it's for this sort of, that's the GPL one, but for this sort of material, don't forget, we're really talking about a mixture of fun and history. Right? We're not talking about commercial organisations.
No, just pick one that's easy for everybody. That's the point.
You might want
Anyway, look,
to fund some of your
if, let's see, there's all the time work on here. Yeah. I think there's, look, do you want to ask questions? I will see if we get the demo back working. We've had it working earlier, but then I'm afraid somebody crashed into the panel. And then somebody else had to unplug the Ethernet cable. So what's happening? I get that magic HTML thing.
Oh, magic.
Yeah. Now, that's those of you who never met an ITL 1900, or those of you who've forgotten it, might have forgotten that there's the main machine, and then a thing called the communications processor. And in those days, remember, everything had 4-digit names, like IBM invented that scheme of things. And then there were teletypes. The plan is to get there instead. With UOC running on the Raspberry Pi, the laptop is the communication processor because the laptop is the thing that can talk to the Wi-Fi in the Science Museum. And if everything goes really well, you guys can log on through the Science Museum Wi-Fi onto this computer and onto George Street on that Raspberry Pi. But you want this to minimize something. Is that? No, I'm sorry. Yeah, well, you see, I'm a hotkey user, and the snag is, a Macintosh's hotkeys are different. Right. Oh, thank you, thank you. Fingers crossed. Yeah. Talk as you time. Now, that's a terminal window running on this machine through this cable, which is just an internet crossover cable, so it's just a private subnet between these two machines. And the it's not actually been switched off, has it, the Raspberry Pi? So the web server should still be running. Let's hope so. Now I have to do, because my teletype emulator doesn't work on here, I have to, oh, sorry, I need to. Now this is actually the Algol 68 demo off that website, completely unmodified. And then now you see George 3 didn't understand lowercase. And then, now those of you who remember George will remember that it was quite possible that you would have got the disk all screwed up and have to restore it. However, that usually takes time, though on here it's quite quick, but I still think we'll resist that temptation. And it wants to know if we need to take a configuration report from that communications unit. And there you are, bing, look. There it is, George ready. Now those of you who remember George 3 will remember that getting from nothing to there is rarely that quick. Now, I need another terminal window. I do shell, don't I? New window. Yeah. Now, if I use a telnet command, and what did we say it was 192 dot. No, we won't. I'll cheat to make sure it works. I'll do localhost. Now it says line closed. Do you remember George 3 when he wasn't working? It said line closed, and he said rude words, and then went away and put the kettle on. Because you see, we have forgotten that we need to look at the communications first. And it's got lots of stuff, so let's do a mop on 57. And it seems to have said something over on this window over here. This is George 3, mark A67, and you can log on. Password well, there isn't one. And you can do a list directory to list all the files you own, which it's not a very rich set. And this is, you can then do compile, which is Malvern's Algol 68 system. Compile test 1. Run it. And you can then execute it. Also, we have some jobs, and they're on card reader number 4. So we can do a Control B for an operator action, engage reader 4, and bingo, off it goes, doing some things. And there it is. And that is all running for real on that. How do I get me web browser back? This helps. Yeah. And could be that if you click that. There's no open trackle. Sorry, there's some old output there left from the previous room. But there we are, that's what's just done. From the card reader job. You look, 1638 on 18th of October. George 3, by the way, was Y2K compatible. So, of course, any body who's used George a lot. Can I move that over? I'll minimise it. I'm sorry. What I was going to do was to use the fact that you could tell the executive that something was wrong and you wanted to post-mortem. And he said, "You want to post-mortem?" "Yes, I'll run on the line printer." It took quite a long time to print all that happen on the line printer. However, today's line printers are rather faster than they were all those years ago, and it's already done it and finished and productive. So I think I get there. And if we go right down to the end, you know what? Something's let me down there. I need a refresh, I'm sure it will. Where they're fine gone. I've probably got to think about it. Which is a refresh on it? On the opposite side from everywhere. And then if we go right down, there's grocery. Remember those? There it is. Look. So you used to put it in a box, send it off to ICL. There's the executive emulation, and all that lot. Send it off. And that was, and then ICL came back with a fix. And it cost you for the next time. But being serious, look, I like to think that what we've done there is shown something that gives the flavour of the original machine, and the mirth around the room suggests that, at least in the nostalgia context, it's working. The challenge is to make it work in the history context. And it's all running on stuff that was written in 2003 or earlier, and it's running on hardware that was manufactured in 2012. And hardware that only became available in 2012. So I'll leave you at that point, but afterwards, if you want to faff about, see if you can log on to the watch system and do what you try.
Well, thank you very much to Jeremy, Tim and David for three very different approaches to the challenges of conservation.
Well, I think Tim and I have got quite a lot in common,
So Tim said we should be shocked and surprised. Well, yeah, sure. But we've also been informed and entertained. So thank you, all three of you, very much indeed. And now, let me just tell you about the next meeting, which will be on November the 15th here. And John Hutchins will be telling us about the history of machine translation. Importantly, and we've already been reminded, and we will be reminded again, but it will begin at 2 o'clock to enable those of us who want to get to the memorial service for Brian Oakley over at the British Computer Society to be able to do that afterwards. So,
there's a meeting in Manchester on Tuesday.
Right, and there's a meeting Tuesday the what? The 23rd. Tuesday the 23rd, if you can get to Manchester.
But I can't remember what it's called.
It'll be on the website. So thanks very much for coming.